Okay, now we're going to do the second example. Same slide this time. It's still slide 6 and page 4 of your notes, but we already did the first example in the last recording that I did. So now we're going to do the second example. So this one right here refers to the same equation. And so we're still using the NaHCO3 plus the HCl equation for this. But this time they are asking if 2.27 liters of gas are produced at 26 degrees Celsius and 745 torr when 2.6 liters of HCl are added. What is the concentration of the HCl? Concentration is what we're solving for here. Concentration, automatically you should think of molarity, big M. Big M equals moles over liters. So we want our final answer in moles over liters. Molarity is concentration. So let's look at what we have here. They give us that we have 0.98 atm. That's our pressure. We're going to use the ideal gas law here to solve for number of moles. And 27 liters is our volume. N is what we're solving for. 0.0821 is our R value. All the units that go with that, you know about that. And our temperature is 299 Kelvin. When we solve for N is equivalent to 1.08 moles, and this is of the CO2. Okay, because they're saying if 27 liters of gas are produced. Well, the only gas that's produced in this reaction is up here, it's CO2. So that's what they're referring to in this problem. Now this is not what we're solving for. We're not solving for moles of CO2. We eventually want to find the concentration of HCl. So we're getting closer, but we're not there yet. We need to take our moles of CO2 and convert it to moles of HCl using our balanced chemical equation. Well, if you refer to the balanced chemical equation, they react in a 1-to-1 ratio. So if I have 1.08 moles of CO2, according to my balanced equation, 1 mole of CO2 is equivalent to 1 mole of HCl. Both have a coefficient of 1. So therefore, if I have 1.08 moles of CO2, I also have 1.08 moles of HCl. Okay, so now that I have my moles of hydrochloric acid, all I need to do is find the molarity. Molarity is moles over liters, and for every 1.08 moles, it is in 2.6 liters, according to the problem up here. So when I take this into consideration, I do the math, it's 0.42 molar HCl. That is the molarity of the HCl that reacted in this equation. Oh, by the way, guys, my first step here, if you're wondering where I got this 0.98 atm, we had to take the 745 torr and convert it to atm first. Kind of skip that step. So, well, I didn't skip it. I just didn't show it to you. 745 torr. Remember, for every 1 atm, there are 760 torr. So divide 745 by 760. That's where I got this value that was originally plugged in for the pressure. So just pay attention to units, make sure everything is consistent when you're doing this problem, because remember the R value that you're using has a pressure in ATM. Therefore, the pressure that you plug into the equation needs to be in ATM before you start the problem. So these aren't very difficult. It's just a lot of steps, remembering to check your units and really read the question, use the numbers that they give you, and figure out how you're going to use those numbers to solve for what they're asking you to solve for.